Hello guys, today I'm going to give you final exam tips on how to totalize functional graph in your final maths paper 2. It is an obvious case, or I can say it is a fact, that you will see a question on functional graph. I will give you tips on how to score 12 out of 12 in your paper 2. So either they are going to ask you to draw the functional graph, or they are going to draw for you and ask you to answer the question using the graph they have drawn for you. So first I'm going to look at option A, where candidates are required to draw. Usually on part A, they will examine you on substitution. They give you incomplete table of values. Make sure you are ready to take your first marks on substitution. I'm going to demonstrate this part A using the question that was in June 2011. So the question is reading, answer the whole of this question on a sheet of graph paper. The velocity of a particle moving along a straight line is given by v is equals to 15 plus 7t minus 2t squared. The table below shows corresponding values of v and t. Find the value of p and the value of q. So as I told you that on part A, usually they are going to examine you on substitution. So the first step here, you need to write the equation as it is. Here we are going to write v is equals to 15 plus 7t minus 2t squared. So our v here is p. We are going to write p, and then we need to substitute correctly. Here we are going to write 15 plus 7. The value of t that is corresponding with p is 1. So we write 1 here, minus 2 times 1 squared. Third step, you need to punch on the calculator as it is. So here we are having 15, we are having plus 7, bracket 1, we close the bracket, and then we say minus 2, we open another bracket, we put 1, we close the bracket, and we write squared. After this, we punch equal to. So can you see, guys, that our p is equals to 20? Can you see, guys, that it is very easy to do the substitution? Make sure you first write the equation as it is, you substitute correctly, you punch on the calculator as it is, and then you find the wanted value. So here we want to calculate q. We are going to say q is equals to, we write our equation as it is, which is 15 plus 7t minus 2t squared. And then the value of t that is corresponding with q is 4. So we write 15 plus 7 times 4 minus 2 times 4 squared. We need to punch as it is on the calculator. So we say 15 plus 7 times 4 is 28 minus 2 bracket 4 squared. We are going to obtain our q is 11. So be ready to take your first marks on substitution. So I will repeat again, giving you the summary on how to totalize on substitution. So the first step is to write the equation as it is. The second step is to substitute correctly. And then finally, you need to punch as it is on your calculator in order to find the wanted value. We are done with the first tip. I'm now going to move on to the second tip. I want to give you the tips on how to draw the functional graph. Usually on part B, they will ask you to draw the functional graph. Make sure you follow the scale provided. Use a pencil that is sharp. Bring at least 2 pencils, rubber and sharpener. And make sure you plot correctly. X coordinate in x-axis should be in line with y coordinate in the y-axis. Try by all means to have a smooth curve, which is eye-catching and smart. Make sure, guys, that you don't forget to label your graph. If it is a velocity time graph, label your y-axis velocity and your x-axis time in seconds, and then you should label the curve. So on part B, the question is reading, using a scale of 2 centimeters to represent 5 meters per second on the v-axis. The v-axis is the y-axis. You should always know that when drawing velocity time graph, velocity is going to be in the y-axis, and then the time is going to be in the x-axis. So we are supposed to draw a graph of v is equals to 15 plus 7t minus 2t squared, from t is equals to 0 to t is equals to 6. We are not given the range for the y-axis, but you should know that it is supposed to be from minus 15 to 15, because minus 15 is the lowest value and then 15 is the maximum value. I'm going to show how you plot the graph. So we are saying that t is our x-axis and then velocity is our y-axis. When x is equals to 0, this is x is equals to 0. Our y is going to be equal to 15. So 0 should be in line with this 15. So we are going to plot a point here. And then 1 in the x-axis should be in line with 20. We calculated and obtained 20 on P. So we are saying 1 in the x-axis should be in line with 20 in the y-axis. It is this point. And then 2 in the x-axis should be in line with 21 in the y-axis. It is this point. 2 in line with 21 is this point. And then 3 in the x-axis should be in line with 18 in the y-axis. So this is our 3 and this is our 18. We plot that point. 4 in the x-axis should be in line with 11 in the y-axis. So it is this point that we are going to plot. And then 5 in the x-axis should be in line with 0 in the y-axis. It is this point. And then finally, 6 in the x-axis should be in line with negative 15 in the y-axis. So it is this point that we are going to plot. After plotting the points, we are supposed to join the points using a smooth curve. Try by all means to have a smooth curve. So it is very important that you label your y-axis as velocity in meters per second, and then you label your x-axis as time in seconds, and then you label the curve that it is v is equals to 15 plus 7t minus 2t squared. You guys make sure that you don't leave your graph unlabeled. I think I'm done with the second objective. Usually most candidates do not struggle at plotting the graph. Candidates will start to struggle when tested if they are able to use their graphs to answer the questions. So on part C, you will be examined to write down minimum or maximum value. If curve is facing up, they ask you about minimum, and if the curve is facing down, for example in this case, they are going to ask you about maximum. So be ready to take your mark. This question is ask you about turning point. So you need to take the y-coordinate of the turning point. For example, here in June 2011 on part C, the question is reading, use your graph to estimate the maximum value of V. So we are going to write the turning point. So here our graph is turning at this point. So you need to take your ruler and then you see the line that is in line with the turning point. So our turning point is this point. It is corresponding with 21. So it means that the maximum value of V is 21. I'm going to explain again on how to find the maximum value of the function. For example, in November 2010 on part B, the question was reading, use your graph to answer the following questions. State the maximum value of the function y is equals to 7 minus 5x minus x squared. So this is the graph of y is equals to 7 minus 5x minus x squared. So we want to find the maximum value. So the maximum value is this turning point. This turning point is in line with 13.5. So it means that the maximum point is 13.5. I think you are now ready to answer the question on maximum and minimum in your final. Just note that when they ask you about maximum and minimum, you are going to write the y-coordinate of the turning point. We are done with our third objective. Let us move on to the fourth objective. We want to solve the equation using the graph. I'm going to use November 2010 question again on B part 2. We want to solve the equation 7 minus 5x minus x squared is equals to 0 using our graph. They are going to ask you to solve the equation using the graph. Do not panic at this stage. It is very simple. For example, let us look on November 2010, number 8, part 2, which was 7 minus 5x minus x squared is equals to 0. What it means here is that you are having two equations. The first equation is y is equals to 7 minus 5x minus x squared. And then another equation is y is equals to 0. So this is the curve of the equation y is equals to 7 minus 5x minus x squared. So this is the graph of that equation. And then the equation of the line which is y is equals to 0 is this x-axis, right? So now we want to find the roots of the equation. We are going to find the roots of the equation by taking the x-coordinates where the two graphs meet. So here we are saying we are having this x-axis. It is also known as y is equals to 0. It is intersecting with y is equals to 7 minus 5x minus x squared at this point and also at this point. So we are going to write the x coordinates where the two lines are intersecting. So here they are intersecting at minus 6.2 and then here they are intersecting at 1.2. So it means that x is equals to negative 6.2 or 1.2. So this is how you use our graph to find the roots of the equation. You just need to write the x coordinates where the two graphs are meeting. So sometimes they are going to give you value which is not 0. For example, in November 2010 on B part 3, we are supposed to solve the equation 7 minus 5x minus x squared is equals to 2. So what we need to do here, we need to draw the line y is equals to 2. So this is the line y is equals to 2. And then to find the roots of the equation, we need to write the coordinates when y is equals to 7 minus 5x minus x squared is meeting with y is equals to 2. So they are meeting at this point, which is minus 5.9, and also at this side, they are meeting at this point, which is 0.9. So it means that x is equals to minus 5.9 or 0.9. We are done on solving equation using the graph. Next, we want to look at how to find the gradient. You should be able to find the gradient. We are going to use the question that was in November 2010 on B part 4. It is reading, find the gradient of the curve at the point where x is equals to 0. So this is our x is equals to 0, which is the y-axis. So we need to draw a suitable tangent at given point. So here we are going to draw this suitable tangent. It is a line that touches the curve at a given point. So it is touching the curve at x is equals to 0. So after drawing the tangent, you need to take end point on that tangent, and then you say gradient is equals to change in y over change in x. For example, in this case, we can take this point, it is minus 1 in the x-axis, and then it is 12.5 in the y-axis. So we said minus 1 is in line with 12.5, and then we need to take another coordinate on our tangent. We can take this point, it is 1.3 in the x-axis and then 0 in the y-axis. So we are saying 1.3 and then 0 in the x-axis. We now need to find the gradient. We are going to say gradient is change in y over change in x. So the change in y is 12.5 minus 0. And then the change in x is minus 1 minus 1.3. So we are going to say 12.5 divided by negative 2.3. We are going to obtain minus 5.43 as our gradient. Let me show you again on how to calculate the gradient of the curve when x is equals to negative half by drawing a suitable tangent. So this question was in November 2007. This is the line which we are naming x is equals to negative half. So we are going to draw a tangent at x is equals to negative half like this. And then after that, we need to find the gradient. We are going to take in 2 points on the tangent. So either we are going to take this 0.4 and also this minus 1, 2. And then we say gradient is change in y over change in x. So it is 4 minus 2 over 0 minus minus 1. 4 minus 2, we get 2 divided by 0 minus minus 1, which is 1. So it means that the gradient here is 2. We are done on how to find the gradient. Next, we want to find the area. Again, we are going to use the question that was in November 2007 on part 4. It is reading, use the graph to estimate the area of the region bounded by the graph the x-axis and the lines x is equals to 3 and x is equals to 4. Make sure that you pay attention to the region which you are supposed to calculate the area. For example, here in November 2007, they are saying the area of the region bounded by the graph. This is our graph. And then the x-axis, this is the x-axis. And the x is equals to 3. This is x is equals to 3. And then x is equals to 4. This is x is equals to 4. So can you see, guys, the region that they want you to calculate the area? They said the graph, which is this portion, and also they said x is equals to 3. This is our x is equals to 3. This is our x is equals to 4. And then this is the x-axis. So they want you to calculate this portion, which I've shaded. So can you see, guys, that it is roughly a trapezium? We are going to say area of this region is, so our A, we are going to take this length, which is 2 units. And then our B, we are going to take this length, which is 8 units. And then our height, we are going to take this 1 unit. So we say half times 2 plus 8, which is half times 10 times 1. We are going to obtain our answer is 5 square units. So make sure, guys, that you pay attention to the scale that is used. For example, here, the scale was 2 centimeters to represent 2 units. That is why we said this length is 2 units. And then this one was 8 because we can see that there are 4 boxes. But since the scale is 2 centimeters to represent 2 units, we are going to have our length is 8 centimeters. And then in the x-axis, the scale is 2 centimeters to represent 1 unit. So that is why we wrote 1 unit here as our height. So we are going to obtain our area is 5 square units. Make sure that you don't leave the units. So another way of calculating this area is we can come here and complete this so that we are going to have a rectangle, and this unshaded is roughly a triangle. So we say area of rectangle minus area of triangle in order to get this shaded region. So want to try that method. So area of this whole rectangle is 8 times 1, which is equals to 8 square units. And then this is roughly a triangle. So the height is going to be from -2 to -8. So it means that we are having 6 units here. And then our base is 1 unit. So we say area of triangle is equals to half base times height. The base is 1 unit, and then the height is 6 units. So we say half times 6, we are going to obtain 3 units, 3 square units. So to find the area of the shaded region, we say 8 minus 3, which is equals to 5 square units. I'm going to demonstrate again on how to find the estimate of the area using the question that was in June 2017. It is reading, find an estimate of the area bounded by x-axis in the cave. So this is the region that we are supposed to find the area. Don't panic because you see that the region is under the cave. You should not panic, but you just need to divide the area into triangles and trapeziums. For example, in this case, this is our x-axis and then this is our cave. We are supposed to find the area bounded by the cave and the x-axis. So we are going to divide the area into A, B, C, and D. So for area of A, you can see, guys, that it is roughly a triangle. So we say area of A. And can we see, guys, that here we are having the same triangles. The triangle A is also equal to triangle D. So we are going to say area of triangle A and B is equals to, in order to find the area of triangle, we say half base times height. So here our base is from 3 to minus 2, so we are having 1 unit here. And then our height, it is 0.6, so we multiply by 0.6. That is the same here. We are having our base from 0 to 1, which means that the base is 1. And then we are having our height from 0 to 0.6. So we are going to say half times 1 times 0.6 times 2. 2 into 2, 1, 2 into 2, 1. 1 times 0.6 is equals to 0.6 square units. So this is the area of triangles A and D. Now want to find the area of trapezium B and C. You can see trapezium B is also equal to trapezium C. So in order to find the area of trapezium, the formula is half A plus B times height. So for this first trapezium, from this point to this point, we are having 0.6. So we write half times 0.6 plus, and then from this point to this point, we are having 0.8. And then the height is 1. This is the same for C. The base is 1, and then this from this point to this point 0.6, from this point to this point 0.8. So we are going to multiply by 2. We say 2 into 2, it is 1. 0.6 plus 0.8, we are going to obtain 1.4. And then finally, we say 0.6 plus 1.4 square units in order to get 2 square units as our area. So this is how simply you find the area when the graph is curved. We are done with our sixth objective of finding the area. Now want to move on to seventh objective of finding acceleration. We are going to use the question that was in June 2011 on C part 2, where we want to find an estimate of the acceleration of the particle when t is equals to 3 seconds. So many candidates, they panic when asked to find acceleration in velocity time graph. It is very simple, guys. Acceleration is rate of change of velocity over time. So it is same as saying change in y, which is velocity, over change in x, which is time. The way you calculate gradient is the same way you are going to calculate the acceleration. So the question is requiring us to find the acceleration when t is equals to 3 seconds. This is our t is equals to 3 seconds. We are going to draw a suitable tangent that is in line with t is equals to 3 seconds. So this is the gradient that we are going to obtain. And then we are going to take n2 points on the gradient. For example, here we can take these 2 and this point. So here, this is our 20, we say 21, 22, 22.5. So 22.5 in the y-axis is in line with 2 in the x-axis. And then this point, it is 4 in the x-axis. It is in line with, so here we are having 10, say 11, 12, 13. So we now need to find the gradient. We are going to say 13 minus 22.5 over 4 minus 2. So let us punch on the calculator. 13 minus 22.5, we are going to obtain minus 9.5 divided by 4 minus 2, which is equals to 2. We are going to obtain negative 4.75. So it means that the gradient is minus 4.75. So here we are asked about acceleration. We need to give our acceleration in correct units. So we are going to say our acceleration is minus 4.75 meters per second squared. Make sure, guys, that you don't forget to write the correct units. So we are done with the objective on acceleration. You just need to, the way you find the gradient is the same way you find the acceleration. And then when you are dealing with acceleration, please don't forget to write the units, which is meters per second squared. And then finally, you're supposed to be able to find the distance traveled. So in velocity time graph, the distance traveled is equals to area under the graph. The same way that we calculated the area is the same way that we are going to calculate the distance traveled. We are going to demonstrate this concept using the question that was in June 2011. The question is reading, use your graph to estimate the distance traveled by the particle from t is equals to 0 to t is equals to 5. So this is our t is equals to 0, and then this is our t is equals to 5. We need to find the area under the graph. So we are going to divide the graph into trapeziums and then triangle. This is our first trapezium. This is our second trapezium. This is our third trapezium, our fourth trapezium, and then finally our triangle E. For our trapezium A, our first length is 15, and then our second length is 20. So we are going to say area of trapezium A is equals to half times 15 plus 20 times our height, which is 1. So area of A is half A plus B times height, which is half times 15 plus 20 times 1. We are going to obtain 17.5. Let us move on to B. Then on B, our first length is 20, our second length is 21, and then here we are having 1 unit is our height. So we are going to say half times 20 plus 21 times 1, which is equals to 20.5. And then for our C, we are having this 21, and this is 18. So we say 21 half times 21 plus 18 times the length, which is 1. So we are saying half times 21 plus 18 times 1, which is equals to 19.5. And then next on D, this is our D. The height is 18 here, and then here it is 11. So we say 18 plus 11 times height, which is 1. So we are going to say half times 18 plus 11 times 1, which is equals to 14.5. And then next, finally, we are having a triangle. We are going to say area of triangle is half base times height. This is our base, which is 5, and then the height is 11. So we say half times 1 times 11 in order to get 5.5. Then finally, we need to sum up the areas. So we are going to say 17.5 plus 20.5 plus 19.5 plus 14.5 plus 5.5, so that we obtain our answer is 75.5 meters. So we obtain our area is, our distance is 77.5 meters. Make sure that you write the correct units. It is 77.5 meters. So this is how we calculate distance in velocity time graphs. So we are done with our option A. This is how they examine you on drawing of the graph. So sometimes they are going to draw the graph for you and ask you to answer the questions. We are going to use the question that was in June 2013. So in this case, the graph was drawn. We're supposed to use the graph to answer the following questions. So on the first question, we're supposed to write down the roots of the equation x plus 1 squared x minus 2 is equals to 0. So here we are having two equations. The first equation is y is equals to x plus 1 squared x minus 2. And then the second equation is y is equals to 0, which is the x-axis. So in order to find the roots, we need to write the x coordinates where the curve is meeting the line y is equals to 0. So they are meeting at this point and at this point. We are going to write our roots as -1 and 2 because that is where the graphs are intersecting. And then on part B, the question is reading, find the coordinates of the points where the gradient of the curve is 0. Please don't panic when asked this question. They are simply asking you the turning point. So the coordinates of the point where the gradient is 0 is the turning point. So here we are having two turning points. This is our first turning point, and then this is another turning point. So we are supposed to write the coordinates of the turning points. Here it is -1, 0, and then here it is 1 minus 4. So those are the coordinates which we are going to write on part B. And then on part C, the question is reading, state the range of values of x for which the function is positive. Can you see, guys, that here from this point to this point it is negative because it is below the x-axis, but when it reaches 2 it is now above the x-axis. So the region where the x is going to be positive, we are going to write x is greater than 2. And then on part D, find the gradient of the curve at the point where x is equals to 1.5. So this is our 1.5. We need to draw a tangent. After drawing a tangent, we need to find the gradient of that tangent. That is going to be the gradient of the line. And then on E, we are supposed to use the graph to solve the equation x plus 1 squared x minus 2 is equals to -2. So again here it is a question on finding the roots of the equation. We are having two equations, that is y is equals to x plus 1 squared times x minus 2, and also we are having an equation which is y is equals to -2. So we need to draw the line y is equals to -2, which is this line. And then after that, we need to write the x coordinates when the line and the curve are intersecting. They are intersecting here, here, and finally here. So we are going to write the x coordinates So here we write minus 1.7, and then here we write 0, and then finally here we are going to write this point, which is 1.7. So it means that our x is equals to negative 1.7, 0, and 1.7. They want to see all those values of x for you to get 3 marks. And then finally on F, find the area bounded by the curve, the x-axis, the y-axis, and the line x is equals to 1. So it is very important, you guys, for you to understand the region that is being defined. So here we want to find the area bounded by the curve. So this is the curve. And the x-axis, this is our x-axis. And the y-axis, this is our y-axis. And then finally, the line x is equals to 1. This is the line x is equals to 1. So can you see, guys, it is roughly a trapezium. So we are going to say area of trapezium is equals to half a plus b times height. So our a is from 0 to minus 2. So we write half times 2 plus, and then from this point to this point we are having 4 units. So we write 4, and then height is from 0 to 1. So we write 1. It is 2 half times a times 6, which is equals to 3 square units. We are now able to find roots. We are now able to find coordinates where gradient is 0. We are now able to find ranges, to find area, and also to find the gradient. Congratulations for following this tutorial. You are ready to score 12 out of 12. More exam tips are on their way. Don't forget to subscribe, like, and share. This is Eve signing out. I love you guys.